In some of my recent discussions, the topic of the Cambrian explosion has been coming up, and I've been seeing a lot of confusion about this topic, especially from creationists. So I thought I would address it today, talk about what caused the Cambrian explosion and what came before, because these topics are very often misconstrued, and the name itself is one of the most confusing things for people. Almost as bad as the Big Bang in terms of causing people to misunderstand what's really going on. So let's get into it. Welcome to another Based Theory. This is Grayson. Many people think that all of these diverse phylum of early life, like trilobites being the most famous example, just appear out of nowhere in the fossil record. They just come out of nowhere. They're in one layer, the Cambrian, and they're not in the layer before. So this seems like just a sudden explosion of all this diversity of life. And that's the way that it's sold a lot of the time. Not even just by creationists, but a lot of the times in textbooks. Now, granted, our knowledge about the time period before the Cambrian is a lot newer. The Ediacaran period, as it's called, only became an official geologic period in 2004. But that's not to say that we know nothing about this period. Certainly we know enough about Ediacaran life to dispel this very outdated notion that all of these groups just come out of nowhere in the Cambrian fossil record. We, at this point, know of over 200 different species in the Ediacaran period. So we've got a pretty good idea. And these species are weird. I mean, they are very strange. A lot of them don't seem to match neatly into any of the categories that we're used to with certain phylum. And it's difficult to trace back what the exact evolutionary relationships between some of these organisms are. But that's not to say that we can't see any obvious precedents to some of the life forms in the Cambrian. So let's look at the example that's often cited the most: trilobites. People say that trilobites just appear out of nowhere in the fossil record. There's no precedence, and they just appear fully formed. Well, that's obviously not true. These people are just ignorant of the Ediacaran. For example, just look at a few of these species of Proarticulata. This is a group of animals, obviously, before Articulata, which is things that include like arthropods such as trilobites, as well as annelids, which are segmented worms. So this is before those groups differentiated. You can see that these look a lot like trilobites, don't they? There are some obvious differences, like the lack of limbs or eyes, but just visually, anyone can see that the trilobites didn't just come out of nowhere with no precedence beforehand. Some of these look a lot like trilobites. In fact, the average person on the street would probably mistake a lot of these for trilobites. Like, look at Sprigina, for example. I mean, the average person on the street would look at that and absolutely think that that's just a trilobite. Some of these examples, I mean, you have a broad diversity of forms in Proarticulata that all look very trilobite-like. Now, we don't know exactly the lineage of when arthropods broke off from this group, or we don't know the exact relationships here, but come on. You can't tell me that trilobites just appeared out of nowhere when we have all of these Proarticulata fossils staring you right at the face. No one can look at these and then say that trilobites just appeared out of nowhere with nothing coming beforehand, no precedence. Obviously, we don't know which were the exact transitional fossils, which were the exact lines of ancestry that led to trilobites. There are differences, like the lack of limbs. We don't know how Proarticulata moved around. And the exact symmetry, though it is bilateral, just like trilobites, the exact symmetry, you'll see that it's not matched symmetrically. It's a little bit staggered. However, I don't necessarily think that this is as big of a leap as some others. I mean, it's very easy for me to think of a sensical mutation that would cause this exact transition. Whereas you have each little node along the development pathway developing either to the right or to the left. If you have a mutation that creates each node to to spread both left and right simultaneously, then that instantly changes the body symmetry of these organisms. So it's not very difficult to fathom that a mutation would be able to change such symmetries. And in addition to segments being duplicated and being able to evolve into limbs. So it's not a huge leap of the imagination to get from certain proarticulata to trilobites. In fact, Spergina even has two little indentations along its head that very well could have been very early and primitive eyes. So what led up to the Cambrian explosion that would have caused what we see in the fossil record? What created the timing for it? Why did the Cambrian explosion occur when it did? Well, let's look at the period before, right? The Ediacaran came before. And what came before the Ediacaran? Oh, right, a massive global ice age that covered the whole Earth. I mean, not a very good time for large multicellular animals to evolve, would it? So, logically, it makes the most sense that you'd have to wait until after this global ice age in order to start the evolution of larger life forms, right? Very logical. And what was the period immediately after this snowball Earth? Oh, right, the Ediacaran period. Exactly what we've been going over. So you already have this immense diversification and radiation of new types of multicellular life forms right when it makes the most logical sense for that to be occurring before the Cambrian. So again, it's a little bit unfair to think of the Cambrian as being this unique explosion of new life forms when that literally had already just occurred right in the period before it for very logical reasons. What else would have contributed to this large-scale radiation and diversification of new life forms? Well, after this snowball Earth massive ice age period, obviously there's going to be a lot more photosynthetic organisms spreading around the world now that the seas are much warmer. And what does that lead to? Right, a lot more oxygen. And we can actually observe in the geology of this period a lot more mineral oxides being present, which are formed in the presence of high amounts of oxygen. So there's a lot of evidence showing that oxygen levels were increasing at this time period. More oxygen in the environment means you can have a larger organism with more fast-acting metabolism, exactly what would be needed for multicellular life to evolve. So the timing of these events makes sense given the geological history of the Earth for these massive radiations of multicellular life forms to occur right when they did. What else would contribute? Well, there's also the fact that a lot of these Ediacaran life forms had gone extinct towards the end of the Ediacaran period. We actually see in the Ediacaran fossil record a large-scale decline at the end of the Ediacaran. And what is reflected in the fossil record whenever there's a massive die-off and extinction event, what typically follows when conditions ripen again is a massive diversification of the surviving life forms. This would explain the Cambrian explosion occurring immediately after the Ediacaran extinction. So why is it that we see all of these fossils from the Cambrian? Well, there is one thing that Cambrian life forms have a lot more of than Precambrian life forms. Skeletons, hard-bodied skeletons, which preserve much more easily in the fossil record. See, before the Cambrian, while you did have some hard-bodied organisms like little spiculas and sponges and things like that, as a whole, we're talking about soft-bodied organisms. We're talking about, jellyfish and sponges and things that don't preserve the best in the fossil record. It takes very, very unique and rare conditions to preserve soft-bodied organisms. In fact, a new study just came out earlier this week discussing some of the conditions within the Burgess Shale that led to the preservation of so many soft-bodied organisms. And they found that it was a very specific type of clay that would cover these organisms with an antimicrobial blanket whenever they sank to the seafloor, thus preserving even the soft-bodied organisms. Now, this type of clay is not very common, and so it makes sense to find these soft-bodied organisms in only very certain specific environments and only very rarely, which is why the fossil record becomes so much more clear in the Cambrian, because all these animals were developing skeletons and hard-bodied shells and things that preserve much more easily and readily in the fossil record, thus increasing the type of visibility that we see in the fossil records. Thus the appearance of some sort of Cambrian explosion of all these new life forms out of nowhere. And finally, and personally, I think that this is the very biggest one that makes the most sense to me, is the evolution of new niches, specifically predator and prey dynamics. Before the Cambrian, we don't have any evidence in the fossil record showing that there were any multicellular predators. And this would be a huge driver of new evolution. As soon as you have one multicellular organism that's capable of eating another, that launches an evolutionary arms race. New niches will develop. That's literally creating an entirely new layer to the food chain, an entirely new niche for new organisms to develop. And when the predators develop, the prey begin to develop to survive the new predators. This feedback loop causes a massive selection pressure to diversify and evolve new traits and new species, leading to the kind of sudden diversification that we see in the Cambrian explosion. And it is worth noting that when I say sudden, we're still talking about over millions of years, okay? When people hear Cambrian explosion, sometimes they think sudden, as in like overnight or over a few thousand years. No, the Cambrian explosion is still over several million years. The Ediacaran period before it lasted almost 100 million years in its own right, okay? That's more than the period of time since the dinosaurs. These were not talking about sudden events here. People hear Cambrian explosion. I mean, it's like the worst term imaginable to describe what's actually going on in the fossil record. People hear Cambrian explosion and they think all this random crazy stuff. Like, all of these organisms came out of nowhere. There's no precedence. They all of a sudden suddenly appeared overnight. It's a complete straw man. It's a complete misnomer. We actually understand a lot of the kinds of conditions that contributed to the Cambrian explosion and the kind of precedents that came before it in the fossil record. So the next time that anyone says to you, oh, the Cambrian explosion is this huge problem for evolution, oh, it can't be explained in the evolutionary picture, just send them to this video. There are tons of great explanations that make complete logical sense and match what we see in the fossil record. The Cambrian explosion is not this huge glaring mystery, okay? There are tons of good reasons explaining why it occurred when it did and what conditions drove this outcome. Plus, the Cambrian and the Ediacaran are just two of the coolest periods in Earth's history. I mean, it really, really looked like an alien planet back then. The kinds of life forms that were around are some of the most alien looking things in the fossil record. It's all immensely cool, and as we continue, like that new study I pointed out is now all of a sudden able to find areas where this clay deposits a lot more frequently. And when we look back at and start doing more targeted hunts in these areas, we're probably going to find a lot more of the very earliest types of animals. A lot more of these Ediacaran species are probably going to be coming to light over the next few decades. And I personally cannot wait to see all the new crazy alien critters that we're going to discover. Anyways, guys, hope you enjoyed the video. Hope you learned something. Stay curious, stay learning, have a great day.